Since time is just movement, the exact proportionality between the four dimensions, 3 of everyday usual space, plus the time exposed by Einstein's relativity, demonstrates that these four dimensions have one and the same nature, the movement. The concept of space depends on movement to exist. It depends on the movements of looking along the three axes, or at least on the movements of traversing them, measuring them with a ruler, for example. When we are at proper rest, the three dimensions of space appear to us to be three straight axes of independent directions. But every straight line is always a curve. A straight line is just a curve that has a very large radius. When we move very fast through space in one direction, the other two of the three dimensions of space bow more proportionally to our speed. The greater our speed, the greater the curvature of space, forming a tunnel effect in the direction of movement. Time also bends and passes more slowly in proportion to the curvature of space and the speed for someone who measures this trip from another frame of reference. The effect of the dilation of our time can only be perceived by observers situated outside our movement, while the greater curvature of space, the tunnel effect, is perceived by those who are moving. It is not exactly correct, therefore, to say that space is formed by three straight dimensions, three straight axes of independent directions. The geometry of space depends on the movement of the observer in relation to things that are neighboring or observable. The statement that space has three straight and independent dimensions is valid only in the situation of the observer's own rest in relation to anything. For the situation of the speed of light through space, the geometric tunnel effect of the curvature of space is maximum. The tunnel is as tight as possible in the view of the traveling observer. The other two of the three straight dimensions of space bend so much that space practically ceases to have three dimensions and is left with only one straight dimension and two curved to the maximum, forming what geometrically, by analogy, we call a line or a string. The curvatures of the dimensions of space are fundamental to the understanding of the formation and functioning of light and matter. The nature of light and matter is not different from the nature of tension in empty space. For light to exist for an observer, oscillation, vibration, movement is necessary. There is never any light at rest in relation to an observer. Light is an oscillation, disturbance or vibration by the tense continuity of empty space. Light is nothing more than movement for an observer. As rest in relation to space can always be admitted by an observer due to the complete physical equivalence always existing between the concepts of rest and motion, due to the perfect continuity inseparable from empty space, which means that in the universe there is no absolute reference for motion. What makes an observer perceive the existence of light is the movement, the oscillation, the variation around the average value of the tension of the empty space that is the light itself, or the matter, made possible by the elasticity of the empty space that is continuous and extensive, and therefore tense, but not in a fixed or rigid way, which one would not expect from a void. When two high-energy photons collide, the result of this collision can appear a proton and an antiproton. For example, in the collision, the variation around the average value of the tension of the empty space is restricted to a small region of great potential energy. The oscillatory motion of linear displacement of the light, that is the photon, curves around a point. The energy of the curved point motion that forms the proton is the proton's rest mass. The proton has rest mass. It has mass when it is at rest with an observer. Photons don't. Photons have mass when in motion. The energy of the moving photon is proportional to the mass of the moving photon. But photons never have rest mass. When a proton is at rest relative to an observer, it is possible to assume that its displacement through space is zero. The time displacement of the proton in this situation is equal to the time displacement of the observer and is the maximum possible relative to the observer. Thanks for watching. Subscribe to my channel and give me your like if you enjoy it.